This next video is a multi-dimensional dynamic arrays. And the way we will create those arrays is we will have to create double pointers. That's if we were making a two-dimensional array, right? So this means that this is a pointer that can dynamically create a pointer, right? For instance, when we create an integer pointer, right? This means that this is a pointer that is able to dynamically create integers. In this case, this is a pointer that can dynamically create pointers. And that's how we will make our dynamic array. So for instance, if with a single pointer, whenever we wanted to dynamically create something, we will say it is equal to a new int, for example, or we could say int p2 is equal to a new integer array. So it's very similar to so doing multi-dimensional arrays is very similar to the single one, except for now if I'm saying integer pointer, then I would have to say I can only create pointers with this pointer. I can't create integers. I can only let me rephrase it. I can only create integer pointers with this pointer and not actual integers, right? So this can only point to integer pointers, not integers. So if I want to dynamically create something in the memory, I have to say is equal to a new pointer, and then I can do that. Excuse me, that would be a new int pointer. Right, so you see the difference. An integer pointer can create new integers. An integer pointer can create new integer pointers. Right, so if I wanted to create a multi-dimensional array, then now I can say that my double pointer, and I'm just going to call it P2, is equal to a new array of integer pointers. And let's say we have 10. So now I dynamically created 10 integer pointers in my memory. So if we look at this, we have something in our memory that looks like this, right? And so now each one of these are a pointer, right? This is a pointer P, this is a pointer P1, pointer P2. You know, of course, these aren't the names because this is just in memory, but I'm just using that for an example. So now we have 5 pointers inside our memory. And now each of these pointers can dynamically create memory, right? So if I wanted each of these pointers to dynamically create an array, they can. And so let's have this one create an array. We'll have this one create an array. We'll have this one create an array. Right, and so forth, so on. So if you see that these are all arrays, if you look at that, now we actually have a two-dimensional array. And so that is how we can dynamically create multi-dimensional arrays. So how do we do that with code? So yes, we will start off by dynamically creating an integer of pointers, but now we have to make each of the pointers inside of that array dynamically create an array. So we are going to need a loop to do that. So we can just say for int I equals 0 while I is less than, and I will just say 10, I plus plus. Now I want to make my pointer that is at I, right? Remember this notation? Each one of those are going to dynamically create a new pointer. So we just say, a new array. right? So now we have an array of pointers, right? So our P is a pointer that can point to pointers. And so now it's going to find that integer pointer and it's going to make that integer pointer create a new integer array. So now we have P pointing to 2D array. All right, and so let me just say that again very slowly. Also, the secret word is donut. All right, so let's start that over again. So I have an integer pointer, meaning that this can dynamically create integer pointers, right? Not integers, but integer pointers. So this is allowed, P is allowed to create integer pointers. So now if I want to be able to make an array of pointers, then I can say P is equal to a new integer pointer array. Right, so now this dynamically created 10 pointers. 10 integer pointers. Right? And as we know, an integer pointer can now dynamically create integers or integers arrays. So if we loop through our double pointer, our double pointer can now, if we dereference our double pointer, right? If we dereference an integer pointer, what do we get? We get an integer. So if we dereference an integer pointer, then we get a pointer, right? So doing dereference and then P plus I is going to actually give me the next integer pointer in my array. And so now that I have that integer pointer can now create a integer array. And so that's how we can dynamically say it equals a new int 10. And so now I have 10 pointers that created 10 arrays. And that's how I get my two-dimensional array. Now, if I wanted to access data or change data inside my arrays, I can use the same array notation as we do with a multi-dimensional. I can say index 0, 0 equals 10. Right? That's how we normally do it in arrays. And so this notation still works. However, until we get used to the other syntax, I don't want you using this syntax just yet. I want us to get used to the other syntax. And so let me explain how that will look. All right, so if my integer P is pointing to pointers, that means when I dereference my pointer, then I actually get a integer pointer. Sorry, yes, if I dereference my double pointer, I get an integer pointer. Right, so star P gives me an integer pointer. So if I say star P plus 1, plus 0, then that gives me the first pointer in my integer pointer array. Right? If I say star p plus 1, it gives me the second pointer in my integer pointer array. Right? So that's how we get the pointer that is actually pointing to the dynamic array. So now if I wanted to actually go to the next index of the array that the double pointer is pointing to, then I have to dereference my pointer, right? That gives me the pointer. Now I want to dereference that pointer that is pointing to, right? So now that gives me the actual pointer. That gives me the second pointer in our array. And now if I want to go through the different index, then I can say plus 1. And that will give me the second index in my second array in my double pointer. Right? So let's just take a look at that. So, well, that's not straight. So let's say I have this array of pointers. Right? So each one of these are pointing, each one of these are pointing to another array. Oh, didn't mean to do that. Oh, tried to make it look nicer. Alright, and then I'll use 3 for an example. Alright, so this right here is an array of pointers. Right, everything inside here is an array of pointers. So that means that each one of these can dynamically create an integer array. Whoa, do that every time. Right, so each one of these are able to dynamically create an array. So if I want to get to this array, I have to dereference this pointer, right? So I dereference p. That gives me the first thing that p is pointing to. So if I want to get the second array, then I say dereference p. Dereference p. Oh, Lord. Excuse me. All right, so if I want to get to this array, then I need to say dereference p. That gives me the address of this array, right? Because pointers hold address, and so it's holding the address of the pointer array, of the pointer. And so if I want to get to this particular one, then I say star p plus 1. Now I'm at this array. Now if I want to get the first index of this array, then I need to dereference that, right? And then that will put me here. Now if I wanted to go to, let's say, the third index, then I will say dereference it plus go up 2. And now I can access this. So if we were in a loop and we wanted to initialize all of our values in our dynamically created multidimensional array, we would do a for loop, a double for loop, int I equals 0, while I is less than, we'll just say 3, I plus plus, And then inside here, I'll do my next loop for int j equals 0, while I is less than 3, while j is less than 3, j plus plus. And now I can say I want to dereference P. Let me move that in a little bit closer. I want to dereference P plus I, and that's going to take me through every single index in my outer array and my double array and my double pointer array. Then I want to dereference that. Now that's going to bring me into my individual array. Right? And now if I want to go through that, then I just say plus J. And that will give me, and then I can just say that equals 0. Right? This is going to give me the address. Yeah, that would give me the address so that I can actually change the value. Yeah, and so to make it a little bit cleaner, we could fix that, put those in parentheses. But yeah, that's pretty much how we will dynamically create, that's how we can iteratively put values to our multi-dimensional array. So now let's talk about how we want to delete if we want to deallocate memory to our array. So with an integer array, an integer pointer, if I allocated memory this way, right, if I just created an integer, then deleting that integer would be delete P. And of course, with an integer pointer 2, if I dynamically allocated an array, then I would have to say delete, and then I would need to put the brackets in P. So it's pretty much the same thing. So when we're using an integer pointer, then that means that I unfortunately I can't do this. It would be nice if we did something like this, right? If we were able to just say, all right, delete P. That would be nice if we can do that. But unfortunately, I'm sorry, it would be nice if we could just do this with two, either one bracket or two brackets. That would be nice. But unfortunately, we cannot do this. So that won't work. The way we have to do it is we would need to go and loop through each of our array. So we have to say for int I equals 0, while I is less than 3, I plus plus. Then we would need to say delete, and since each of these pointers dynamically create an array, we'll say delete array, and then we'll say star P plus I. And so that will go through every single pointer inside of this double pointer array. Since those pointers dynamically created arrays, then we use the array bracket to delete that particular pointer. Then finally, once we do that, then we just say delete, and since P was a array of integer pointers, then we have to use the array bracket, and we'll just say delete P. And so that's the way we will delete multi-dimensional dynamic arrays. All right, thank you, and sorry for the long pauses.